All right, this is a video on right triangle trigonometry, specifically looking at finding the lengths of unknown sides in right triangles using trigonometry. We'll start with a quick summary overview and then do a couple solved examples. So as a summary of trigonometric ratios, I have a right triangle here where the vertices are labeled A, B, and C, and typical convention has those vertices labeled in capital letters. And then the sides are labeled in lowercase letters A, B, and C. And I hope you can see that, for example, side A is across from vertex A. So that's just a typical geometric notation for labeling sides and angles in triangles. When we're working with trigonometry, in this case, we are only able to do what we're going to do in this video with a right triangle. So the triangle has to be a right triangle. And here I'm showing, obviously, that angle C is a right angle. There are three trigonometric ratios we'll be working with today: sine, cosine, and tangent. And I'll summarize those for you right here. I'll talk about a mnemonic for memorizing them, and then we'll apply these ratios. I really want you to think of these words, sine, cosine, and tangent, as simply representing the ratios of side lengths in a particular triangle, okay? And we'll talk more about that down the road. Let's say we're working with angle A, and let's call that the measure of that angle theta, okay? We can say that the sine of theta, and we'll abbreviate sine as S-I-N, don't pronounce it sin, I'll pronounce it sine. The sine of theta is the ratio of the opposite side to the hypotenuse. Okay, so in this particular case, it'll be lowercase a over lowercase c. Okay, it's always equal to the opposite over the hypotenuse. It won't always be equal to a over c because we might be working with a different side or angle of the triangle. The cosine of theta, not pronounced cos, pronounced cosine, is equal to the ratio of the adjacent side divided by the hypotenuse. And in this case, it's going to be b over c. And the tangent of theta, pronounced tangent, not pronounced tan, is equal to the ratio of the opposite side divided by the adjacent side. So, and in this case, it'll be a over b. So the first thing that I like to do when I'm given the angle that we're working with, theta in this case, I do what's called, what I say, label HOA. HOA stands for HOA. Okay, H stands for the hypotenuse, so we'll label the hypotenuse with a big H. O stands for opposite, the side or the leg opposite the angle we're working with. So in this case, A is the opposite, so I'll label that with a big O. And then adjacent means next to. It's the leg that's next to the angle we're working with. It's not the hypotenuse, it needs to be the leg. So working with HOA, okay? Hypotenuse, opposite, and adjacent. So it's super useful to label those. And then of course we are labeling these legs as A, B, and C as well, but those mean different things, okay? Let's actually apply this a little bit using a particular triangle with particular sides, okay? So here we have a right triangle. Sides of 7 and 25 are the legs, and then 24 is the hypotenuse. And there's a mistake here, I hope you can see it. The hypotenuse can't be shorter than the leg, so I am going to trade those around. Sorry about that. And I am going to double check the Pythagorean theorem right now just to make 100% sure that this works. Yep, now it works. Okay, so we have legs of 7 and 24 and a hypotenuse of 25. And let's say we're working with this angle theta down here. So first thing again, label HOA, so label the hypotenuse, the opposite, and the adjacent. And it doesn't matter what orientation the triangle has, how it's rotated around or whatever. We really just start with the angle theta that we're working with, and it's often trickiest to label the opposite and the adjacent sides, but just be careful with that. So let's write out what the sine, cosine, and tangent of theta are. Sine, cosine, and tangent of theta. So the sine of theta, remember, is the opposite over the hypotenuse, which is 24 over 25. The cosine of theta is the ratio of the adjacent to the hypotenuse, which is 7 over 25. And the tangent of theta is the ratio of the opposite divided by the adjacent, which is 24 over 7. Okay. We don't know exactly how large angle theta is right now, but if we did, we could go to our calculators and determine the sine of that angle and realize, and we would get as a result in our calculator of these exact ratios for the sine, cosine, or tangent. One thing I forgot to mention earlier is a mnemonic for remembering these. And I'm going to highlight some key letters. You've probably heard this mnemonic before in class. And we say SOHCAHTOA. Okay, so just to be clear, that SOH stands for the sine is the opposite divided by the hypotenuse. The CAH, cosine, is adjacent divided by hypotenuse, and TOA is tangent is opposite divided by adjacent. Let's actually apply this in a real-world problem, which we'll solve in two different ways. So this is the Leaning Tower of Pisa, and the vertical height from the ground to that point right there is 150 feet. Okay, sort of that upper, one of the upper balconies. The angle between the vertical and the edge of the tower is 5 degrees, as you can see here. And I'm curious in what the amount of horizontal overhang is. So let's find that. Let's call that x. Okay, so let's use trigonometry to determine that distance. So I'm going to, let's redraw that triangle, and I'm going to draw it a little bit less to scale, just so we have some space to work with. So let's call that a 5-degree angle, and let's call that x. Quick thing before we get going on our calculator, you want to make sure you are in degree mode. In the window of your calculator, there might be a little D. If you're on a graphing calculator, maybe hit the mode button, and you want to check to make sure you're in degree mode as opposed to radian mode. Another way to check this is to take the sine of 30 degrees in your calculator, and if you get 0.5, you should be in degree mode. So let's work with this triangle we have, and again, I'm going to try to solve this two different ways for you. And let's call this angle theta, and as I've been saying, let's label HOA. So we're going to label the hypotenuse, the opposite, and the adjacent. What you want to do next is really eliminate the side of the triangle that you don't care about. We don't know the hypotenuse, and we don't want to know the hypotenuse. So I'm going to literally cross it out, okay? So all we care about are the adjacent and the opposite sides in this particular case. We know the adjacent, and we're looking for the opposite. So the only trig ratio that involves the opposite and the adjacent is tangent. So let's write that out. Remember that tangent of theta, and in this case, it's the tangent of 5 degrees, is equal to the opposite leg divided by the adjacent leg. Okay? We could go to our calculator and literally find the tangent of 5 degrees. It's a decimal, it's a ratio. And I encourage you to write out at least 4 decimal places. So round to the 4th decimal place. Go further if you're motivated to, but I wouldn't go less than 4 decimal places. Okay, and now we just need to solve for x. So we're solving a proportion. We can multiply both sides by 150. These 150s cancel, leaving us with just an x on the right-hand side. And I get x is equal to 13.125, and I'm going to round my final answer to 2 decimal places, those 13.13, and that would be in feet. And think about it, does that make sense? It looks like in the Leaning Tower of Pisa, it looks like it could be overhanging by about 13 feet. We're going to solve this a different way to show you another way that, that we can use trigonometry to solve some problems, or another scenario you'll come across. So let's let's get this triangle drawn again. So same situation, same triangle. We still have a right angle. We have 150 feet. That's 5 degrees. And we should be able to figure out pretty easily that this would be 85 degrees, knowing that the angles in a triangle sum to 180. Let's work with this as our angle theta now. Okay, so this horizontal base is still our x. We could still label HOA. This is our hypotenuse. In this case, the 150 is the opposite and the x is the adjacent. We're going to eliminate the side we don't care about. We don't care about the hypotenuse. We don't know it. We don't want to know it. Once again, the only trig ratio that uses opposite and adjacent is tangent. So let's write out tangent. Remember, tangent, in this case of 85 degrees, is opposite divided by adjacent. 150 divided by x. Okay, I'm going to do a couple things differently this time. One thing that's different is the x is in the denominator, so we have an extra step in order to solve for it. The other thing that's different is I'm going to not do the tangent of 85 in my calculator until the very end. And I'm trying to model how to get a more exact final answer without doing any intermediate rounding. So let's multiply both sides by x. And we have these x's cancel. And what do we end up? We end up with x times the tangent of 85 is 150. I multiplied both sides by x because that initial x was in the denominator. I wanted to get everything out of the denominator. Another thing I did not do, I did not write tangent of 85 times x, because in that case it would be unclear. Are we talking about the tangent of 85 times x, or are we talking about the tangent of 85x? We're actually talking about the former, tangent of 85 times x, but it's much easier to just write the x out front, and then you don't need to worry about needing parentheses or misinterpreting that expression. Let's divide both sides by the tangent of 85 to get x by itself. Remember, the tangent of 85 is a number, so it's okay to just divide both sides by a number, although it might be an unfamiliar way of dividing than what you've done before. But we get an answer of x is 150 divided by the tangent of 85. And now what I want to encourage you to do is just go to your calculator and try to just do this in one sequence of steps without having to write down any intermediate numbers. And I get an answer of 13.12 feet. So a little bit different from my initial answer. It's 1/100 of a foot off just because we didn't do any of that intermediate rounding. But that would be my final answer right there, just over 13 feet using right triangle trigonometry. And that is a great place to stop.